Okay, gentlemen, we're looking at the notes we took last video on the factoring intro. We talked about factors, and we did some multiplying with polynomials. I never gave you an example like this. I'm going to give you some of those today. Nothing crazy, not a lot of them, but just a couple, probably like one foiling and then a couple like this, just so we get used to kind of multiplying binomials by trinomials or trinomials by trinomials, and then listing them in descending power order. We talked about factoring. All of these had my number in front of the x squared as 1, which made all of the little side work pretty easy. And then on the problem set I gave you after the factoring intro video was all factoring with stuff like this, or we had a couple with 2 terms and a minus sign. We saw a couple with radicals on the homework. Answer key is posted for you. We didn't do this yet, but that's going to become imaginary, which we will do very shortly. But today what I wanted to do, and write these notes, which I'll write down here so we see it and hear it. Write these notes below last video's notes. Okay? And then you'll submit either part of it, or you can kind of resubmit if it's all like on one page, right? Like I'm kind of close to the bottom of a page, so you could just resubmit it and say second half, next video. Again, I want to see that you took notes during the video, so I know you watched it, because that helps me move on from there, right? These aren't missed class days, but it doesn't mean that I'm supposed to come into school and then reteach it all. I do assume that you have comprehended some of it. Okay, so a couple things first. So again, your classwork is going to be some multiplying, and I'm kind of writing this down for myself as well. And then a little bit of review of last video, so those ones we did, and then a couple of the second tier factoring problems. Okay, and here's how we do. So here's some of the second tier factoring problems. We saw some like this, right? X squared minus, 16, right? Actually, that's a bad one. I'll do 9, okay? And we saw that this was 2 terms. It's a minus sign. I can write this as x minus 3, x plus 3. We also saw some that were not perfect squares, right? We did that one with the 8, which we can kind of see at the top over here. What happens if I give you something like this, right? The one I kind of wrote already, x squared minus 16. Well, 2 terms, minus sign, we've seen this, x minus 4, x plus 4, right? If I were, in red, to change that 2 to an x to the 4th, and then in your notes, do it like that. Right? I'm kind of just reviewing here, but write this one, x to the 4th, it's like I have here in red. X to the 4th minus 16. It doesn't stay x minus 4, x plus 4. We square root this. X to the 4th square rooted is like 2x squareds. 2x squareds. Now these two are different because this is x minus 3, x plus 3. This is x squared minus 4 and x squared plus 4. So when I go from x squared, I drop it down to x and x. X to the 4th, I drop it down to x squared. But we've done stuff with x squared and minus signs before. We see up here x squared plus, we don't know how to do yet, right? We're going to be able to kind of do more with this later. We don't know how to do that yet. But what x squared minus 4, we've done this. We know that can break down more into x minus 2, x plus 2, because this is 2 terms. Perfect square, nice. It works out really good. But even if it's 2 terms and a minus sign, I can do more to that, right? And we're looking at here saying okay, so how do I know when I can do more and how do I know when I can't? Well, this is x squared. It drops down to x and x. This is x to the 4th. It drops down to x squared. I have to get them as best I can to all be x's to the firsts. This one's not, but it's plus. And we don't know how to do that yet. Okay, we don't know how to do the plus yet. Okay, so that's an important one to understand. I'll just kind of write down here, get them all prime. The factors that is. The factors is what I mean by them. Get them all prime, meaning x to the first or x squared or anything plus a number, right? A number, just like I have over here, right? That's going to be, prime because we don't know how to get down to it yet. So for right now, that's kind of our goal. But really our initial goal is get stuff to x to the first. Just like if I were to say 6 and you say, oh, that's 3 and 2. But if I say 24, you say 6 and 4. I say keep going. 3 and 2, 2 and 2, right? This is like this. You just get one answer. Boom, boom. This is like this. You can do it twice. So you're going to see a couple of these on your homework where there's like x to the fourths. What else could I see related to difficult two-term things? What happens if I do like 4x squared minus 25, right? Same thing. I have two terms and a minus sign, so I do the same exact thing. Two sets of parentheses, square root of 25. I just said it is 5 and 5. I know one's plus, one's minus. Instead of it just being x, there's a 4 in front. So now it's 2x minus 5 and 2x plus 5. Okay? 4x squared. If this were a 4x to the fourth, this should be a 2x squared and a 2x squared, right? Unlike the one right next to it, this obviously is like a plus, right? So again, we have to do more later. But this is 2x squared minus. This one's going to look really weird because it's going to be like radical 2x minus radical 5. So I'm not really going to give you many that have like that x to the fourth up here and then can break down more like I have it crossed out here in red. A lot of times I'll keep it like this, so then this would be your answer, right? Just to kind of reiterate that, because I can keep going, but then they get pretty weird with the radicals. Okay, to accelerate this video a little bit, so those are two more versions of the two-term things. You'll see a couple simple ones of these, a couple of these where you can break it down again, and then a couple of these. So I'm going to do these three examples here. Okay, you're going to have something like this, 2x squared minus x minus 10. So again, it's a three-term thing. But again, I'm going to do the same thing I did, but I just had something like x squared minus 3x minus 10. It was the same idea, but now I have a 2 in front. Well, what did I have to do for this one up above? I had to find two numbers that multiply to the term, the number in front of the x squared and the number in the back, including the sign. Now the number changes, negative 20. It used to just be like kind of whatever this number was, but now it becomes negative 20. I'm looking for two numbers that multiply to that negative 20 and that add to the middle term, which is a negative 1. Number in front of the x. What two numbers do that? Negative 5 and 4. Pick those numbers pretty quick. Now the difference here, different because the number in front of the x squared is greater than 1. So that is greater than 1. We have to do this process where we take the 2x squared, we take the minus 10, and all I'm going to do, oops, I like yellow, is take this middle term and split it up into the two numbers I have over here. Minus 5x plus 4x. Okay, so there's my two numbers, negative 5 and 4. And if I notice, if I combine them, negative 5 and 4, I would get my negative 1. So I'm going to rewrite them here, except it's a negative 1x. So I'm going to take the negative 5x, take the positive 4x, because I'm just taking this middle term and like expanding it in a particular way that I picked over here. Okay? Now, right, I want to find the greatest common factor. Now, this one's a little weird because the way I wrote it, right, it would kind of be better if the 4 were by the 2 and the 5 were by the 10, because they're going to, like, pair up. And it doesn't really, like, the 4 and the 10 aren't as nice as the 2 and the 5. But it'll still work. I'll do it this way, then I'll show you like what happens. Like what if I didn't do it that way and I kind of wrote the 4 there and then the 5 over here. Like what happens if I wrote it like this? You would get the same answer and it actually would be like a little bit nicer, but it doesn't really matter. It's the same process. I want to find the greatest common factor of just the left-hand side. So I have a 2x squared and a negative 5x. The only thing they have in common, the only common factor, is an x. And then I have 2x minus 5 I'm left with. Take out an x, take out an x. I just have 2 and 1x, and then minus 5. Same over here. I want to take out my greatest common factor. Well, not x stuff, but now it's going to be numbers. I have a 4 and a 10, so that means they both have a 2. If I take a 2 out of 4x, I get 2x. If I take a 2 out of 10, I get 5. Would you look at that? This right here matches with this right here. Okay? That should happen every time as long as you do it right. That should happen every time as long as you do it right. And now the only thing I have to do is write my final answer. You did all the work. That was it. Do you get a set of parentheses that matches? That gets written once down here. Once. 2x minus 5. And then what about the stuff in front? Well, this x and this 2 get written like this. X plus 2. Okay? And that would be my answer. I have factored correctly. I have this, which I broke up to a negative 10 with my 20. Then I have my negative 1. I want two numbers that add to that. So here they are. I rewrite them as a breakdown of the middle with x's, and then I GCF the left 2 and the right 2. Okay? I could do the same over here. Where what happens if I put the 4 first? I would get the same answer. GCF is now a 2x, because they both have a 2 and they both have an x. I'm left with x plus 2. Okay, so once I take a 2x out of here, I just have a single x. Once I have a 4x out of here, I just have a 2. And then over here, I take out a 5, and I have x plus 2. Take out a negative 5, because this is all negative stuff, and I need it to be positive, so take out a negative 5, I have an x. Take out a negative 5, I have a positive 2. Would you look at that, they match, which I was hoping for. And then here's my 2x and my minus 5. The two numbers in front of both of that duplicate parentheses. Now, if you look, I had x and a 2, and then 2x minus 5 twice, which I wrote once. Same thing over here, 2x and 5. There it is. And my parentheses is now the x plus 2. So you're just GCFing out the other part, but it's the same answer. The same answer. Okay? So let's do another 2 examples if we can, if we have time. Whoops, 2 more examples. 3x squared minus 5x minus 12. 3 terms, so I don't do my whole, is there a minus sign? I do the square rooting thing. Nope, I'm looking for 2 numbers that multiply to negative 36. And then at the same time, add to that negative 5. I'll pick the numbers for the sake of time. 9 and 4 will multiply to 36, making one of them negative. I choose the 9 to be negative because I want them to add and give me a negative 5. Now I keep my 3x squared, I keep my 12, and all I'm doing is splitting up the middle term into these 2 numbers, a negative 9x and a positive 4x. Right, so these numbers jump into a split of the middle, and they get x's attached to them. GCF on the left, they both are multiples of 3, and they both have an x. And then I am left with a 3x out of an x squared, an x. 3x out of a 9, x, would just be a minus 3. Erase this. for space. And then over here, again, I'm looking for a GCF. I have a 4x and a 12. They both have a 4 in there. And then I'm left with an x, a minus, and a 3. I take a 4 out of 4x, I have an x. I take a 4 out of a 12, I have a 3, and it's negative. Do my little parentheses match? Yes, so I did it right. There it is written. And now here's my 3x. Here's my 4. I don't have a sign in front of it, which means it's plus. If it were negative, I would have written it. There's my answer. You could always FOIL this out. If I weren't sure, I would say 3 times x. 3 and 3 is 9 plus 4. There's my negative 5. There's my negative 12. So if you're ever unsure, multiply these and see if you get it back to where you started. I'll do one more example, and then we'll cut this video. Okay, so there's my 4x squared minus 16x plus 15. Again, 3 terms, so I'm looking for 2 numbers that multiply to the first number in front of the x squared and the last number, which is 60, and adds to negative 16. Again, I'll pick the numbers. I need it to be a 10 and a 6. They have to get to a negative 16, so they're both negative. Multiplying 2 negatives do give me a positive. Sometimes those are actually the trickiest ones for me. These 2 numbers are used as a split up of the middle term. Okay, there's my 10 and there's my 6x. Similar to what I said before, right? Sometimes you want to position these numbers pretty good. I did over here 2 ways. I thought it was easier to do the GCF way, this over here. But if you prefer just to throw them together and you're going to GCF it, you're going to get the same answer, fine, do that. I kind of like to choose to put my numbers in a good spot. So we look over here. Right, it wouldn't have really made sense if I put the 4 there, the 9 there. It would have still worked, but the 4 and the 3 aren't really good numbers. Over here, it doesn't matter. 10 and 15 or the 6 and the 4, like, it's kind of the same. So let's just leave it as is. GCF, greatest common factor of the left-hand side. It's an x. And a 2. Not a 4, not the whole 4, just the 2. Right? So when I do that, I'm left with, so I took out a 2x from a 4x squared, leaving me with a 2x. I'm taking a 2x out of a 10x, so that means I'm left with a 5, and it's minus. So this already looks different because most of the time my parentheses, this one had a 2x minus 5 in it as well, but then over here it didn't. So it's a little bit of a weird one because this doesn't go out so evenly, but it still works. Greatest common factor here. Well, they both have not a 6, not a 2, but a 3. A 3 would work. Okay? This right here, negative sign, is kind of hidden here, but I'm going to take out a negative 3, so that means I'm left with a 3 from 6x. Would give me a 2x. So I'm looking like they match. If I took out a positive 3, I'd have a negative 2. It doesn't match. It needs to match. Okay? Then I have over here, took out a negative 3, so now my 15 is going to be, I'm taking a negative 3 out of it, and there it becomes a negative 5. Here's my 2 parentheses that match. And then here is the 2 numbers in front. I'll write those in red, 2x minus 3. And those are my 2 factors that when multiplied together would bring me back here. Are all 3 of these examples I did, are the answers prime? Are the answers prime? Are the answers prime? Well, here I have x's that are to the first power. Those are prime. Here I have x's to the first power. Those are prime. I did it the other way. X's are still prime. It's the same answer. X's are to the first power. So all my answers are prime polynomials. Not really numbers. Polynomials. I read it like that. Right? So that's the equivalent of like 3s and 2s and 5s and 7s. Those are prime numbers. You know, something like 6 and 12 and 4 and 8 are not prime numbers. You can do more to them. These, you can do no more to. You got it down to its prime most version, which is just with an x to the first. Okay, so you have a couple problems to do. Again, there'll be multiplying, review, and then a couple of these second-tier factoring problems. Okay? Good luck. Let's go, Islanders.